Hi there, Year 10s. I hope this finds you well and ready to go for today's session. What I suggest is you sit and listen through this video PowerPoint and then use the accompanying worksheet, go through the PowerPoint slowly to fill it in or to create your notes. So let's get going. So group 7 on the other side of the periodic table is the non-metal group we study. We've got fluorine, chlorine, bromine and iodine. And there we go. Fluorine is yellow, chlorine is a green gas, bromine is an orangey brown liquid, the only liquid non-metal on the periodic table. Of course, mercury is the only liquid metal. And then we have iodine, which is a black solid or a purple gas. And there we can see bromine is very volatile, which means that it forms a vapor very quickly. So one year when I knocked over a bottle of bromine, although it was a liquid, in no time it vaporized and it ended up all over the labs. It wasn't one of the best days in my teaching career. Okay. So we need to know some of the uses. Chlorine is used for sterilizing water. When they put chlorine chemicals into a swimming pool, they don't put the gas, that wouldn't be very good at all, but they put a chlorine compound. Bromine is used for making pesticides and plastics, and it tends to be a very poisonous gas. And then iodine is often used in the amazing medical profession to sterilize wounds, and you see that lovely brown color on the skin as they do that. So what are the physical properties of the halogens? Because they are non-metals, we know they're going to form simple molecular structures. So that's just thinking back to your work on covalent bonding. And we know that the halogens, really unique to them, they form diatomic molecules. Diatomic molecules. Really important to remember that when you're writing word equations. So non-metals, they form very strong covalent bonds, but then if I have one chlorine molecule and another chlorine molecule, there's a very weak intermolecular force of attraction between them. Inter means between, like an inter-house competition, and because of that weak intermolecular force of attraction, it's very easy to turn it from a solid to a liquid to a gas, and that's why the melting points and boiling points of the halogens are relatively low. So that explains that point. They are non-metals, so they don't conduct heat and electricity. And we need to know about the pattern. So the melting point and the boiling point increases as you go down the group. That's really important to remember. Right, so your next heading would be the chemical properties of the halogens. Because they're in group 7, they would all have 7 electrons in their outer shell. Very easy to identify. They all want to be like the halogens, but they only need to gain one more electron to get a full outer shell. And they can either do this with ionic bonding, so they gain one electron from the metal atom. And when they do that, we call it a halide ion. So you might get sodium chloride or sodium fluoride. So you change the ending to IDE for the halogen, and we call it the halide. And because it's gained one electron, it has a 1- charge. It can also form a covalent bond. So chlorine can join to another chlorine atom, or it can join to hydrogen to form hydrogen chloride. So they can form covalent bonds as well, sharing one pair of electrons to get that full outer shell. So here's an example of ionic bonding, a bit of a blast from the past. You've got sodium and chlorine. You can see over there the chlorine is going to gain that extra electron, there it is, to get a full outer shell. And I now draw it with a square bracket and a minus charge, which is focusing on the sodium chloride over there. Sodium forms a 1+ charge because it lost that one electron in the outer shell. And this, because of opposites attracting, chemistry is all about love, they come together, that very strong force of attraction. And here we have, just to extend you a little bit with calcium, we have got 2 electrons in the outer shell, so one calcium electron is going to go to one atom, and the other calcium electron is going to go to the other fluorine atom to form a fluoride charge. Okay, so just been beautifully interrupted by Mr. Gregson, but we shall march on. There's some more examples of covalent bonding. You can see over here how we are sharing that electron, so that hydrogen's got 2 electrons in its outer shell and it's full, and chlorine has now got 8 electrons with that extra one, so it's got a full outer shell and it's now stable. And over here we can see the bonding between 2 chlorine atoms. So that one's now got 8 electrons in the outer shell, and the one on the right has got 8 electrons in the outer shell. Now you don't need to know these equations, but these are just some reactions that show you that unlike the alkali metals, where the reactivity increases as you go down the group, with the alkalis they increase as you go up the group. So these experiments show exactly why they are so different. So why is it that fluorine is so much more reactive than bromine or iodine? Well, we know they all gain that extra electron on its outer shell to get a full outer shell of 8 electrons. And what we notice is with bromine, that extra electron that it's trying to gain is far away from the protons in the nucleus, and therefore, because the distance is so far away, just like a long distance relationship is a little bit difficult, it doesn't have the pulling power to bring that electron in. But if we looked at fluorine, that electron that was coming in here is much closer to the protons in the nucleus, and therefore it's much easier to pull it in to form that full outer shell. So that's why fluorine is more reactive than bromine. We also need to know about displacement reactions. Now, we've come across displacement reactions when 2 metals are competing with each other. Halogens can compete with each other as well, and it's exactly the same principle. So over there we've got Mr. Sodium with Miss Iodide, cute shorts, and Miss Bromine. Now, as we know, bromine is more reactive than iodine in group 7. So bromine is going to be able to quite rudely kick Miss Iodine out the way and get together with that rather handsome Mr. Sodium. So there we go, sodium iodide plus bromine forming sodium bromide. Remember, when a compound is made out of 2 elements, the second element ends in IDE. And poor Miss Iodine is all on its own, so what we'll actually see is a purple color start to form in the test tube because of iodine now on its own as the element iodine. This is asking about, we'll talk about that in a moment, the iodine over here is being removed, and they describe that as being oxidized, but we won't look in that in too much detail right now. Here's another example, potassium bromide, and along comes, oh, that's quite a six-pack, Mr. Chlorine. And of course, as you can guess it, quite predictable, Miss Potassium gets to win Mr. Chloride and gets left, poor Mr. Bromine gets left all on his lonesome. So what we're going to see, because bromine is displaced, we're going to see a orangey brown color forming, which is characteristic of bromine. And this over here is the symbol equation. So get into the habit of writing the word equation and don't mix up the words with the symbols. AQ means it's in solution, like if you put salt in water, salt water, that means potassium bromide water. Chlorine is in solution in this example, and it's going to form a bromine solution as well, which is why they're using the AQ sign. Really important to remember, it's Br2 and it's Cl2 because they are diatomic molecules. Right, so if we have to add fluorine to potassium chloride, can you guess what is going to happen? Which one's more reactive? Is it the fluorine or is it the chloride? You're quite right. Fluorine is more reactive, so it's going to be able to kick away, or the scientific term, displace the chlorine from the potassium chloride. So chlorine is going to be left on its own, and you're going to get potassium fluoride forming. Okay, and over there is a list of some of the things that we need to understand in this topic. And next for you to do is to use the worksheet I have supplied to create notes about these important points. Lots to take in. I'll give you time for plenty of practice. Take care, look after yourselves, and keep on challenging yourselves. You are amazing, and I'm missing you. Take care. Bye-bye.